Alright, let's go through and capture our final analysis. We're going to be doing a Factorial Anova. For this example, Dr. Rickert wonders whether there's a difference between men and women and the effects of attractiveness on defendant sentencing. To study this, she randomly selects 60 men and 60 women and randomly assigns them to read a scenario featuring a defendant who is attractive, unattractive, neutral. 20 men and 20 women read each of the 3 defendants' scenarios. Fill in the blanks for the following Factorial Anova. Our total still equals the sum degrees of freedom is going to be how many attractiveness groups minus 1. There was 3, so that's 2. How many genders minus 1? 2 minus 1, so we have 1. Then to get this, we multiply the 2 groups together. We do attractiveness times gender, so we're going to end up with 2. Error equals how many are in each group, so this is going to be going to be 3 times 2 times 20, because there are 3 different attractiveness scales, scenarios, 2 genders, and 20 people per one. So it's going to be 3 times 2 times 20 minus 1. And then it's going to add up to 119. It's going to be all the total people minus 1. Degrees of freedom is going to be used in our mean squared. It's going to be sums of squared divided by degrees of freedom equals mean squared. Same thing for the rest. Now what's different here is we are always going to calculate F obtained dividing it by our error. We now have 3 F values. We now need 3 F criticals. Alright, we're going to end up with 2 different ones. We're going to end up one with for attractiveness. We use the degrees of freedom 2 for the numerator. We'll end up at 3.07. In this case we use 120 because it is so much closer as our degree of freedom for the denominator. It is so much closer to 120, 114 that is, than 60. Next we're going to use 3.92 and then 3.07. From this we can see that this one's significant, oops, not significant, sig, and not. The null hypothesis, there is a main there is not a main effect of attractiveness. Remember, null means no, so the alternative would be there is. And then the last one is there's not an interaction of gender by attractiveness. We know that the only effects that are significant is going to be gender, because F obtained is greater than F critical, and we know that there's a difference between men and women because there's only 2 there. Alright, for this one, we're going to calculate the effect size. And it's going to be sums of squares for the effect divided by sums of squared total. So in this case, it's going to be 62 point. It's going to be 193.23 divided by 1,686. So it's going to equal so we end up with roughly 11.5%. APA style, this is written the same way as APA for a within subjects ANOVA, which you can look at the within subjects ANOVA video for that. The difference is we break it down into 3 separate sections as we have 3 separate hypotheses.